Most people are used to seeing waves break as they approach the coast, but at a few locations around the planet, there are special waves that break for miles and miles inland. They're called tidal bores, and in this video we're going to explore the science behind why they happen. And at the end, we're going to hit the road and find one. And spoiler alert, we might try to surf it.
What the hell am I doing?
The ocean is filled with waves. Little capillary waves that sailors look for when searching for puffs of wind, steep choppy waves that can turn a boating day into a wet and wild ride, and swells that travel long distances and sometimes break beautifully on reefs and coastlines to the delight of waiting surfers. While all of these waves have distinct characteristics, they also have one thing in common. They are disturbances in the surface of the water that are created by wind. Tidal theory tells us that the gravitational fields created by nearby massive objects, like the moon and the sun, will produce a bulge of water on the sides of Earth closest and farthest away from them, and low points of water in between. As the Earth rotates, these watery high and low points stay in the same place relative to the sun and moon, creating daily, monthly, and yearly fluctuations in the ocean water levels that we call the tide. The movement of the watery high and low points around the planet is called a tidal wave, and it's similar to the ocean waves we've already mentioned, except it has a much longer wavelength. In some parts of the world, the tidal wave approaches as a visibly breaking wave called a tidal bore. But why does this happen in some places and not others? To explain this, scientists model the coastline as a simple inclined plane. As the tidal wave passes, sea level rises and falls, and the position of the water's edge moves in and out. The incoming water would also travel faster and farther up the coast. The key here is to identify two variables that can lead to incoming tides traveling farther distance inland in a short amount of time: high tidal amplitudes and low coastal slopes. Keep in mind that some parts of the world have larger tidal amplitudes than others, and a high tidal amplitude is one of the two ingredients needed to create a tidal bore. The second ingredient is a gently sloping coastline. But where on earth does that happen? The answer is rivers that flow into the sea. Some rivers have very steep slopes, and water flows down them vigorously, driven by Earth's gravity, while others are gently sloped and water flows down them slower. As luck would have it, there are approximately 50 locations on Earth where large tidal ranges and gently sloping rivers result in the creation of a tidal bore. To visualize why this happens, we can use the metaphor of an airplane creating a sonic boom. If a plane is traveling slower than the speed of sound, then the sound waves it creates will run ahead of it, and no boom is created. Conversely, if the plane is traveling faster than the speed of sound, then the sound waves it creates will get left behind. But if the plane is traveling at exactly the speed of sound, around 343 meters per second, then the sound waves it creates travel along with it and build up over time into a large pressure wave we call a sonic boom.
Called a bore tide.
And there it is. Not as impressive as other bore tides I've seen on YouTube, but still very cool to see. I mean, I've seen people surfing on these bore tides. I guess this one wasn't large enough. Bore tides, or tidal bores as they are also called, are pretty rare. They only happen in areas with a large tidal range, and it has to be a shallow, funnel-like bay or river, like this one. And here we can see the strong current entering the turn-again arm. Take a look at that.
for watching. If you'd like to support the channel, links are in the description.